Excellent. I've been quite lucky in that we've had access to multiparametric MRI for probably about 15 years now, where Mark and I work at UCLH. And we have had two areas which we have strived to work on. The first was actually getting any acceptance that MR could detect tumour at all. And I remember a trip Mark and I took to New York where we were laughed out of the building when we suggested that MR might be able to detect tumour. And the other is the importance of using this technique properly. And that is that the scan quality is standardized throughout Europe and the United States and the rest of the world, and also that the radiologists report to in the same way. And your meeting today about focal therapy, it is crucial that the MR imaging is the same. Otherwise, your trials, what you're trying to do with the patients, will not work, and the results you get will not be able to be looked at between various units. So I'm going to start with some results that were given at ASCO this year in Chicago by Hash Ahmed. This is Mark's, who's the main investigator on this trial. This is the PROMISE trial, looking at the ability of MRI to detect cancer. It's been a long time in gestation. Mark and I were on the plane. Mark said 8 years in gestation. And we were looking at the ability of MR to detect both rule in and rule out significant tumour within the prostate. And this was a cohort of over 500 men. They had a 12-core prostate biopsy, and they also had a 5mm template transperineal mapping biopsy. Significant tumour was given as Gleason 4+3 or a cancer core length of 6mm. So this allowed us to also rule in lower Gleason scores, but of a larger volume. And one of the things I'm talking about today is PIRADS, but in this particular cohort we used actually Likert scoring, which I'll talk to you about as well. So the results of that showed that the sensitivity of multiparametric MRI to rule in significant disease. I'm hoping that this works as a laser. Oop, don't want to shine it at anybody. If we have a laser pointer, that would be brilliant. The ability of multiparametric MRI to rule in tumour was 93% versus a truss biopsy of less than 50%. And more importantly, the negative predictive value, so that's allowing you to say to a man that he may not need a biopsy, was 89%. We were also talking on the plane that actually we've gone right back to the beginning, because Arnaud Villiers from Lille presented almost identical data 10 years ago with the same sort of sensitivity and negative predictive value for MRI. So we've almost just reinvented the wheel. What's interesting for me as a radiologist was our ability using a scoring system to identify men who were likely to have significant cancer versus those that had no tumour. And this was a Likert score, a very easy 1 to 5 score, whether or not we thought there was cancer present. So one of the things that we've been trying to do over the last 10 years is to try and make the technique and the reporting of MRI more standard. And we started this back over 6 years ago now, when we had a meeting at UCH where we brought together all of the groups in Europe who were doing a lot of MRI to try and form a consensus, not only on how to do the MRI, but also how to report it. And this ended up as a document from the European Society of Uroradiology, where the initial PIRAD version 1 guidelines were drawn up. This has subsequently been superseded by PIRADS version 2, which is what I'm going to talk to you about today. A slightly controversial way, but nevertheless what the committee that decided PIRADS 2 wanted to do is they wanted to form a standard where everybody was reporting in the same way. It has its problems, which I'm going to show you, but nevertheless, it was a start. So the initial guidelines were published 2012. They had the technique of how you should do the multi-parametric study, and that required you to do a T2 weighted image, a diffusion weighted image. PIRADS version 1 did not require you to do dynamic contrast enhanced images, but PIRADS version 2 does. So let's have a few examples. Oops. So I'm just going to show you what a multi-parametric MRI looks like, for those of you who haven't seen one. Is it possible just to have this light not shining at me? It's just I can't see the computer at the same time. Thank you. Thank you, Mark. Whoa. all my contrast resolution has gone. So Mark's been showing you some MRI. So what MRI allows you to do is we have some T2 weighted scans which show you good anatomical detail of the prostate. Tumours are shown as areas of low signal on this study. We usually do the T2 weighted scans in both axial and coronal planes so that it allows really nice, good definition of the prostate, the seminal vesicles, the ejaculatory ducts. We then apply gradients and we form a diffusion sequence, and we look at that in two ways. One is by making a map looking at the areas of water restriction, and the other is by having one of the high gradients sitting beside it. And what we're looking for is areas of restriction of water movement, and they look black on this study and they look white on this study. And the reason for having them side by side, which is now a requisite in PIRADS 2, is so that you don't overcall areas of low signal on the ADC map, which actually are not restricted, and these are areas of fibrosis. The other thing that we need to do is we need to show whether or not there's any enhancement within the prostate, any enhancement of tumour, and again we can do that by having a scan performed before we give contrast, followed up by a scan after delivery of contrast where the prostate enhances, and we can look for areas of early enhancement. We've gone away from having to do quantitative analysis, and we're now using a visual inspection of the early wash-in phases of the scan in order to be able to detect tumour. So let me show you a few tumours now so you can get your eye in as to what we do. Just find those. Still blinded by the light here. So this is a prostate of a gentleman with a raised PSA. And I think it's very clear to see that he has an abnormality which would be totally impalpable arising from the anterior aspect of the gland. It's homogeneous, T2 low signal. We're going to now look at the diffusion characteristics of it. So I'm going to put up the ADC map next door to the long B value, and you can see that the area that is restricted, so low signal on the ADC map, is high signal on the long B. And if you scan through the prostate, you can see the extent of that tumour all the way to the sphincter, and in fact wrapping around the sphincter. If we now look at the early phase of the enhancement, and you can see, I'm going to scan both side by side, you can see the abnormal enhancement with a little bit of less enhancement centrally where he's got a little bit of necrosis. Anterior tumours come in all shapes and sizes, and I'm just going to show you another one. You have to look everywhere, and there are areas in the prostate where we can miss tumours, and this is one of them. And of course this would be very much an area that might be missed at biopsy. So you look at the prostate and you think, well, that looks pretty normal, a little bit of signal change in the peripheral zones. When you come to the apex of the gland, if your radiographer has cut the apex off, you might actually miss this large area of T2 low signal, perhaps best seen on the coronal views. Really very apical again, a difficult area to biopsy and a difficult area if you didn't know that it was there to actually identify tumour. Again, it has all of the abnormal parameters, it shows restricted diffusion, and it also shows enhancement. So what we do for all of the prostates is look at these four basic sequences and identify tumours. So I'm just going to show you a couple in the peripheral zones now so that you can get an idea about peripheral zone tumours. So again, they're usually seen as areas of low signal. I'm showing you some obvious ones. There's some non-obvious ones coming up. Area of low signal. Low signal on its own in T2 can also be infection, it can be prostatitis, it can be areas of atrophy. So again, we need to make sure that it does all the things that it's meant to do. So it shows restriction. You can see beautifully how the long B confirms what you see on the ADC. And often after targeted and focal treatment, it's the long B that shows us the areas of tumour that recur rather than the ADC map, which can be very difficult because of the fibrosis that you get following treatment. And again, the early enhanced phase just shows a little bit of focal enhancement against a background of diffuse enhancement. And I'm going to show you an even smaller one now, just so you can see how small MR can go. And this is a very small tumour, which you can just see on the edge of the lateral edge of the prostate, on the long B of the ADC map. We're just getting a little area of restriction on the ADC map. You can hardly see it on the T2 weighted scan, and you can just see a little bit of focal enhancement on that. So it's a matter of using all of the sequences to their best effect. So let's go back to the talk now. So initially what we did is we split the prostate up into 16 zones and we scored them using a grid basically as to whether we thought there was tumour or not, and we measured 3 lesions. We used a Likert score, which is basically a 1 to 5, not suspicious, highly suspicious. Likert allows us to use our clinical judgment as well as what we actually see in front of us. And we were scoring to the yellow and the red on the disease profile that you can see there at the bottom of the slide. So PIRADS 2 changed this slightly, and I think it is important to see how rigid the PIRADS 2 system is, because I think this explains why the PIRADS misses some of the smaller tumours. So this came up in 2014, presented at the RSNA. It is a consensus, and it is meant to be a living document. It was a deal really between the United States and the European radiologists as to how best to standardize how we do the scans, how we report the scans, and also to try and report the scans in a way that would be easier for people attempting focal treatment to know where the lesions were. Unfortunately, it meant splitting the prostate into 36 zones, a little unwieldy, and I suspect that will change. And it also changed what we were scoring to. So clinically significant disease stayed at a Gleason score at or over 7, but the volume that we were trying to identify increased to over 0.5 ml, plus or minus the presence of extracapsular extension. And this was a little contentious. It almost made the MR too easy to read, and a lot of oncologists were worried that small volume tumours can be important too, and indeed they are. So it's very rigid. There's a 5-point scale for T2 and for diffusion weighted, and just a 2-point scale for the dynamically enhanced scans. And there are very rigid qualifications for you to do that. And one of the reasons for that was so that the inter-observer variability between radiologists would narrow. The other thing is that despite giving all of these values, you don't add them up and divide by 3. Some of the values are more important than others, and the diffusion weighted value is more important in the peripheral zone, and the T2 weighted value more important in the transition zone. And again, a little bit contentious, and I'll show you some contentious ones in a minute. So this is the structure of PIRADS 2. This is for the T2 weighted scans. Again, this is 1 to 5, so very unlike LICAT. It actually tells you what you need to look for, and you are not to take in any clinical feeling that you have about the patient. So a PIRADS 1 for the peripheral zones is beautiful, homogeneous T2 high signal with no focal areas of abnormality. A2 is areas of diffuse change. I'm sorry I don't have a pointer. It's a bit... areas of diffuse signal change and also areas of linear signal change. And a 4 would be areas of focal T2 low signal. And I think one of the more contentious things about PIRADS 2 is, although you might be convinced on LICAT that that is a tumour and give it a 5, on PIRADS 2 you can only give a 5 to those lesions that are greater than 1.5 centimetres in diameter. So that's one of the major differences between the two systems. So 2 large tumours. In the transition zone, the 1 to 5 changes because the transition zone is a very different beast to look at compared with the peripheral zone. So these would be 1s and 2s, well encapsulated low signal nodules would be 1s and 2s. This would be a 3, an area of homogeneous signal which you can't draw around, not quite sure whether that's an adenoma or whether it could be a tumour. And again, tumours like we've shown now in the anterior gland, homogeneous, poorly defined margins. A raised charcoal sign is one of the other things that we look for. And again, this is directly invasive coming out of the anterior margin of the gland. So a similar 1 to 5, this time for diffusion. This would be a normal diffusion. You can see the ADC map and the long B, just as I've shown you in a real patient, showing no areas of high signal and no matched areas of low signal. That would be a 1. I don't have, this would be a 4, so this is also what I've shown you, an area of high signal on the long B with a matched area of low signal on the ADC. And again, the difference between a 4 and a 5 is size, whereas with LICAT, it would just be clinical impression that there's tumour there. The dynamic enhancement now becomes easy. It's either there or it isn't. And the interesting thing is how you put all those scores together. And I'm not sure that many of us who are doing PIRADS do this. I must admit I'm still very wedded to LICAT, and after our PROMISE data, I think we've shown that LICAT works very well. But this is what you need to do. So in the peripheral zone, you take your diffusion number. T2 weighted doesn't particularly matter. You see whether it enhances or not, and then you attribute it a PIRADS number. And again, in the transition zone, you take the T2 number. The diffusion doesn't matter. The diffusion does matter. It tells you whether or not you've got more or less likely to have a tumour, but the dynamic enhancement doesn't matter. And I think most of us who do a lot of prostate MRI know that this rigidity really doesn't exist in real life. And of course, T2 weighting is useful in the peripheral zone, and of course, dynamic GAD is useful in the transition zone, but PIRADS takes no account of that. So there have been some papers looking at the ability of PIRADS to detect tumour, and you can see that they're actually less than our PROMISE data using LICAT. There have been some papers looking at the difference between LICAT and PIRADS. This one from François Cornu in Paris showing very little difference. And then this one recently published from Sloan Kettering, basically showing that PIRADS 2 limited with small tumours, picked up only 24% of them, which is actually a very worrying feature, and this coming from whole mount radical prostatectomy, so there may be a bit of a bias in that. So my problem with PIRADS 2 are some of these. Based on the MR findings only, your clinical impression of your radiologist is not incorporated into that. Concept of a dominant sequence seems a little bit rigid. The key is we now need to use contrast, and you cannot use PIRADS if you do not have all the sequences that you need to use to score. The other thing is that PIRADS is explicitly just for the initial MR exam and not for active surveillance or to be used post-treatment. In order to be a PIRADS 5 lesion, it needs to be invasive. So I'm going to show you a few examples of that. But before I do, one of the other things with PIRADS is just the fact that we have to give you a better reporting system than just a verbal report, a written report like this. We looked in the UK and we found that when radiologists are just allowed to report without some sort of structure, they end up giving in less than half the reports the relevant data that's needed in that particular group of cancer patients. So one of the things that we've tried to do was to give you a report that generates images and diagrams as well as numbers, and this is a typical Likert report. And some of you will have systems whereby we're actually contouring lesions so that you'll get a report that gives you in multi-planes the whole contour of the tumour, and of course this is hugely useful if you're going to plan focal treatments. So let me just show you a couple more. Got just a few minutes, and I'm just going to show you a couple more lesions, and I'll show you what some of the companies have been trying to do in order to help with PIRADS. So this is a gentleman who has got two big tumours. He's got one in the peripheral zone here and one in the transition zone here. And this particular program that I'm using, and one of the reasons I wanted to use my computer, so thank you very much for that, is it's got a PIRADS help for the radiologist. So what I do now is it's got T2, diffusion, dynamic GAD. So all I have to do is I say, I've got a lesion there, and it's in the basal third of the prostate, so it's going to be there. And that is less than 1.5 centimeters, so that is a T2-4. I think the next one is also got tumor in it, so I think I'm going to put both of those. Don't think it goes into the, perhaps goes just into the central gland, so into the mid gland, so I'm going to do that. And then I've also noticed up here I've got some homogeneous low signal too, so I'm going to colour in this one too, and I'm going to put that as a 4 as well. So I'm now going to go to my diffusion scan, so I'm going to click onto my diffusion scan, and I'm going to put my diffusion scans up. And I can see that, I'll just move my document out of the way, so you can see that I've got matched defects, so I'm happy about that. So up here I'm going to call that a 5, because I've got more than 1.5 centimeters diameter of tumour, and here I'm going to call that a 4, and that one. And then I'm going to now go to my dynamic GAD, and we're going to see what those tumours do. Whoops, sorry, pressed the wrong bit. And so I've got nice homogeneous enhancement of the anterior tumour. Whoops. And of the other tumour. So I'm going to say that is positive, and that's positive, and that's positive. So my little chart then also allows me to put in the size, but you can see that I've now generated a PIRADS score of 4. So that would be a Likert 5, undoubtedly, because that's definitely tumour, but it's a PIRADS 4. And this will also then deliver a report that I can give to my consultant, and it's going to be here, and it's got the pictures, and it's got the pictures, and easy, quick. 3-4 minutes. So that may be to have something like that on our reporting system. Certainly in the UK, we're a long way from that. But I just wanted to show you before I finish, and I'm almost finished, just one lesion that PIRADS would undercall, just to show you the problem with the system. And this is a gentleman with a raised PSA. And if we look at the T2 weighted scan, very difficult. For some reason that's not working. Very difficult to see any abnormality. We've got this diffuse T2 low signal, which on PIRADS would be a 2. And if we have a little look at the matched pair of diffusion scans, well, it's a small gland, isn't it? We've got some areas of low signal here, but they're not matched. We've got really normal-looking peripheral zones. So again, we're talking about a 1 or a 2 on the PIRADS system. The interesting thing with this patient is that the dynamic enhancement is so utterly positive, and the PIRADS system does not allow us to take that into consideration. So if I show you the two scans side by side now, you've got the unenhanced and the enhanced, and you can see this beautiful area of focal enhancement sitting in the anterior horn of the right peripheral zone, which was a Gleason 3+4 tumour of about 0.5 mil. If you'd scored that with PIRADS, that's going to be a 2. And so this is the real worry with the system. If you're forced to rigidly access a scoring system. And again, even going back to the diffusion scan, there really isn't an abnormality there. And of course, if you've got slightly diffuse tumour, it may not give you a diffusion lesion, and particularly if the tumour is small. So in conclusion, whoops. Take that away. So in conclusion, I hope I've shown you a little bit about where we are at currently with multiparametric MRI and tumour detection. We've got a system called PIRADS version 2, a little flawed. What it has shown is that junior radiologists, it will up their ability to identify tumour. It will certainly reduce the intra-observer variation, but there is a worry with it that we're going to miss small volume tumours that are still very important. We still, I have to say, at UCH are using Likert scoring, and you've seen the promised results using that. Multiparametric MRI is absolutely technique critical. If you have not got a good MRI, then you should not score it, and you should not report it for tumour, although you can possibly report it for staging purposes. You need to do T2, diffusion, and enhanced scans, and we need to start giving a structured report, and hopefully many of the workstation vendors now are allowing us to, as I've shown you, very quickly deliver a report with both a picture and a score embedded within it. So thank you very much.